Assalamualaikum and hi everyone. So our topic is temperature recording and attendance monitoring. We are from M1G10 and here is the list of our group members. During this COVID-19 pandemic, it is important for us to follow the SOP before entering any premises. The procedure that we should follow is to scan QR code or write our names for the attendance, to scan our body temperature, and to sanitize our hands. Other than that, we should always at least 1 meter away from each other to avoid physical contact. In Malaysia, most of the premises are using a manual way to run the SOP of COVID-19. Due to that, some of the customers did not really follow the SOP given and some of them are using the system in the wrong way. Therefore, our objective is to build an easy system that helps to monitor the customer attendance, to build an automated system that helps the owner to making sure that the customer will follow the SOP of COVID-19.
I'm M1 Maximilian. I'm going to talk about face mask detection of this project. So the purpose of face mask detection is to prevent customer entering the shop without wearing a mask. So this algorithm is based on OpenCV Cascade Classifier Library, and it is an effective object detection done by Viola et al. So we select this algorithm because it is efficient. So the training process of the machine learning model is by preparing positive and negative image of the data, and then we will train the model using the Cascade Trainer GUI by Amadi. After the training is done, a model will be generated as an XML file, and the XML file will be loaded in our program. Next, I'm going to talk about the algorithm of the face mask detection process. So first, when the customer enters the shop, the program will initialize the camera, and then the Cascade classifier will check for the face mask for 100 times. And finally, this is the mask detection result. So as you can see on the figure on the right, when the program found a mask, it will draw a blue rectangle around the region. The next part I'm responsible for is retrieving temperature data from the Cat3 probe. So we are using an aftermarket thermometer for this project. So to retrieve the temperature data, we have to create a serial communication via the USB port on the sensor and the Raspberry Pi. Next, I'm going to talk about the temperature checking algorithm. First, a serial communication is created via the PySerial library in Python. Next, the program will continuously read the serial data until the customer completes the temperature measurement. So the temperature checking result is as shown. When the temperature exceeds a specific value, for example 37.5, a warning message will be displayed in red color. The temperature is normal, the temperature red will be displayed, and a welcome message is also displayed.
Hi everyone, my name is Yunus and I'll explain about smart counting system. So as you can see, this is the hardware component and this is the software component. We use Arduino IDE. So the main idea of the system, it will count the customer who will enter the shop and will give like alert if the number of customers in the shop reach to the maximum. Okay, how the system will work. So we have two IR sensor. The first IR sensor will count. If the first IR sensor will be high, means the customer will go in and it will count up. If the second IR sensor will be high, that means the customer go out and it will count down. So this is the steps. First of all, check the IR sensor. If the first IR sensor will be high, that means the customer go in and it will count up. So now I will explain about Semi app. What's Semi app? This app designed to give alert if the customer who scan his temperature is more than 37. This is the hardware and software component. We use here NodeMCU and we use MIT Inventor to create the app, and we use Arduino IDE as a code who will receive the signal from the NodeMCU. So as you can see, when the customer enter the shop and his temperature is more than 37, the owner will receive like this alert notification in his. So this is the steps. First thing, the customer will scan his temperature. Then the customer, if the customer his temperature is more than 37, the notification will send to the owner through the Semi app.
Hi, I'm Iskandar. So I will present about the sensor, which is my part. Okay, first of all, sensor is to detect a person, customer in and out of the shop. Okay, and then to let the vendor buy sound. This is the hardware and software. The software I use is Arduino IDE, and the hardware I use is, as you can see there, 2 sensors and 1 buzzer. This is the sensor configuration. Okay, when the sensor in detects someone is going in, the buzzer will give a sound that is customer is going in. But when the sensor out is detecting a person is going out, the buzzer will give a sound of when the customer is going out. From the left side, this is when the sensor detects the customer in, so the customer in will add one customer in the shop. So then the right side, this is when the customer is going out. So when the sensor detects someone is going out, so the total customer will be -1. This is the long coding of the sensor. Next part is MySQL. Okay, MySQL is a database server in localhost that collects data and retrieve data. I use Raspbian OS to do the MySQL. This is the interface of the PHP myadmin. Okay, so MySQL is collecting data and saved in local server, collecting which data of this vendors want and can be retrieved back anytime, anywhere. On the left side, it is data example of when the customer in or out of the shop. On the right side, it is a data example of temperature detection of customers.
I'm Shaira, so I am going to continue with automatic hand sanitizer dispenser. This is the circuit diagram, and it shows how the ultrasonic sensor and the servo motor will be connected to the Arduino Nano. So this is the Arduino coding. This is the explanation on the automatic hand sanitizer dispenser mechanism. So if we put our hand more than 10 cm above the ultrasonic sensor, the sensor cannot detect the motion, but if we put our hand between 0 to 10 cm above the sensor can detect the motion, thus the servo motor can operate and hand sanitizer can be pumped.
Next, I'm going to talk about the total project cost. We would like to give special thanks to AR Mechatronics in sponsoring this project. So as seen in the table, we spend the most in the Raspberry Pi and also the K3 thermometer. So for Raspberry Pi, other than the MCU unit itself, we also spend a lot in the peripheral and parts such as the SD card, Raspberry Pi screen, Raspberry camera, and so on.
For conclusion, we achieve our objective to build an easy system to monitor the attendance of the customers, automatic system for the temperature recorder and the hand sanitizer dispenser. Besides, we also be able to build a mobile app for the system. Although some of the systems are not working smoothly, the overall system is running successfully. For instance, a better quality component helps in further improvement of our system.